Alright guys, so we are doing invertible function. So it's part of our lesson 3 uh, of unit 1, composite and inverse functions. So follow along. Alright, so this is our first question here. F is a finite function whose domain is letters A to E. Okay, so we have a table here, and you see that A corresponds to -6, B corresponds to 3, C -6, D 2, E -6. So you see very obviously -6 has 3 x's that points to -6. So one x has 3 y's, okay? So is this original graph, is it a function? Yes, indeed. Okay, so x points to the same y's. That's perfectly fine. It passed the what? The vertical test. Okay. 1x to many y's. Okay. And in fact, if you line it up, it could be a wobbly graph with the wobbly lines, right? But still, it is a function by definition. But if you do the horizontal test, which is how you determine if the function is invertible, because you're switching around, right? You're switching the old y's to x, and you're switching the old x to y's, new y's, right? So in fact, the new table will look like this. -6 will correspond to A, and -6 also corresponds to C and E, right? So you 1x is pointed to many y's now, right? 1x is pointing to -6, which is -6, that is pointed to many y's now. That, in fact, is not the definition of a function, okay? So if you inversed it, it cannot be a function. So after you line this up, you'll see the opposite when you switch the purple to green and the green to purple, right? The domain here and the range here, but you switch around, that doesn't meet the definition of a function. So the first one is not invertible, right? It's not invertible. So you'll see here f is not invertible. Okay, so the next question here, we have different x, right? Different x point to different y's. They each have their own x and y's, right? They're all different. A, B, C, D, E, meaning they are different numbers. And so that'll be it, right? Because they all point to the different number. When you switch around, when you switch your y to x, then it still is different numbers, okay? When you line this up, you wouldn't have the same x that points to many, you wouldn't have the same different x's that points to just one y, okay? So because they have different y's in the beginning to start with, then you wouldn't have to worry about if they switch around. They still are gonna be different. So that meets the definition of being a function when you switch the range to domain and the domain to range. Okay, so
49. Each of the members
so
of the
that is indeed invertible. Okay, so you can draw them on a plane, and you can do your horizontal test to see if it's invertible. If it doesn't pass, then it is not invertible. Okay, and let's go to this right here. Do all functions have inverse function? right? You see here, if it has different y's, different x's that points to different y's, then indeed they are still invertible, right? And different x's here, and does it point to different y's? Right, it did. Okay, so in fact this is yes. Okay, and then let's try another one. I'm seeing here different x's that points to one y. Right, when you switch around different x's, no, same x's that points to one y. So that in fact doesn't work because when you look at it, it does not pass the horizontal test, right? So no. Okay, so here we have the last question, right? The last question is challenge problem, and we have a function here is f of x equals to x to the power of 2. Okay, so if you look at it, what is this? You want to draw this, right? If you want to draw this will become a parabola. Okay, parabola, and it has a original point at 0 and 0, right? It does not shift to anywhere. But when you plug in the 0, first of all, it does not pass the horizontal test. That's the number one thing. Okay, so if it does not pass the horizontal test, you right away know it is not invertible. But if you want to test some points out, we can. Okay, but it's easier to explain it on decimals. Okay, so when you look at decimals here, it's running really slow. Okay, so y equals to x to the power of 2, but if you want to switch around, x equals to y to the power of 2, right? So indeed this is the inverse. This graph is in inverse of this function here, but because you have this y equals to x is right here, the green one is y equals to x, and you fold it, right? You take a piece of paper and you fold it diagonally, then you can print this right on this, right to the blue line here. But when you see here, question 2, it has 2 answers. It points to 2 y's. So this blue line is not a function. Okay, it's not a function. So no. Check. Okay. Goes to x to the power of 3 probably. It's just that the coordinates could be shifted. Let's try it out. Because it curved 2 times, right? So y, where is my y? Equals to x2. 2x2. Okay, so if you have this kind of graph, x to the power of 3 and plus 2 x to the power of 2, then you're starting to curve it, right? Starting to curve it. Okay, so is g invertible? No, right? Is h of x invertible? Yes, because horizontal test, it passed. Okay, it passed. Okay, so you got the trick here, you got the tips, right? And let's do this right here. Restricted domains. Okay, restricted domains to make them invertible. So right away you see a curved function here. This is the graph of cosine, right? And it has been shifted to the right for pi over 4. So in cosine or sine or any trigonometry function, you will have x as in your theta, where you're gonna point to with a pi. Essentially, your x will have numbers that has a pi in it because you're describing an angle, and an angle is described by a unit circle, right? So essentially, you're gonna have pi's, or the numbers related to pi's, as your x. Okay, we'll go over them when we touch on trigonometry, but right now this is a cosine graph. But the important thing is that this is curved, so we don't want the curve function as a whole, because we just want the segments of it where it appears to be a straight line. Okay, so you could see here, this to here, although it's curved on the top, but it's not gonna affect the fact that when you switch from x to y and y to x, it will still point to one point, right? One point points to exactly another point, right? The corresponding point, but the curved one does not do that. All right, okay. So we restrict the domain, meaning your x, right? The negative 5 over 4 is right here, and negative 1 over 4 is right here. Okay, so this one does not work because it's clearly points to, it does not pass our horizontal test. Okay, negative pi is right here, negative pi is right here, and pi, so all the way to here. Still, it does not work, right? It has a huge curve on both ends, so that hopefully this works. Okay, here to here. Okay, negative 2 is right here, and 1 over 2 is to here. Okay, so what works here is not, right? The first one is not gonna work. How about the other one? This one does not work as well. How about the third one? No, right? Because it curved at the top here, so it still cannot pass the horizontal test, right? See how it's done? The horizontal test is just drawing a straight line, a flat line, going across, and if you hit 2 points, it does not work. Okay, so hopefully the last one works. So 1 over 2 pi is over here, and 5 over pi is over here. So it appears to have a little bit of curve at the end, but it does not affect our horizontal test. So the last one will work. Okay, so we choose the last one. Okay, so that's it for this lesson. Hope you get it, and see you on the next one.